So we are covering 6.2 larger systems of linear equations. So the first one is solve by back substitution. So what that means is if you look at the third equation, we have 2z equal to 8. So we can get the z by itself, and then we get the z and then go back to substitute in equation number 2 and then substitute in 1. So we are going backwards. It's called the back substitution. So let's take equation 3. Solve for z. 2z equals 8. So when we divide by 2, we get z equals to 4. Now we are going to substitute this z in equation 2. So let's write the equation 2 so we can get the value of y. So this is equation 2. So now substitute z equal to 4. So we get 3y plus 20 equal to 17. Now we're going to subtract 20 both sides. So we get 3y equals -3. So when we divide by 3, we get y equals -1. Now substitute z and y to get the x. So I'm going to go to the next page. -4 and y equals -1 in equation 1 to get the value of x. So the equation 1 is x plus 4y plus 4z equal to 11. So plug in y and the z value here. Y is -1 and z is +4. So we get x minus 4 plus 16 equal to 11. Combine the like terms, so we get x plus 12 equals 11. Then subtract 12 both sides. So we get x equals -1. So we got all the values of the variables. So the solution is -1, -1, 4. Question number 2, we have to write the augmented matrix for the system. So the system of the equations is 9x plus 4y equal to 5. There are two equations with two variables are given. So what we mean by matrix is an array of numbers in rows and columns. So all we have to do is, without x and the y, we have to write just the coefficients. And for the constants, we have to put the line here. So it separates the variables and the constants. So this is called the augmented matrix. And next example, So this is an example. It's a matrix of 3 by 3, that is 3 variables and 3 equations. So wherever the variables are missing, we have to put 0 because the coefficient for that variable, particular variable, is 0. So the augmented matrix is so the first one we have 9. There is no y, so it's going to be 0, and then 9, and the constant is 54. The second one, there is no x variable, so we are going to put 0, -2, 8, 2, then 7, 7, 3, 83. So this is the answer for number 3. So the problem number 4 is the other way. We are going to write the equations from the augmented matrix. So this is the matrix we are given. Now we are going to write the equations. So let's take this variables as x, y, and z. So this is going to be x, y, and z, and that's the constant. So from this one, I can write x equal to 6 because y and 0 are z are 0. The second one, there is no x and z, so y is going to be -7. And the last one, we get x is 0, y is 0, and z is going to be 9. Number 5, we have to perform the row operations. It says replace R2 by R1 plus R2. So here R1, R2 means row 1 and row 2. So R1 means row 1, R2 means row 2. So the given equation, the matrix is 1, 0, 2, -1, 1, 3. So first we have to add R1, R2. So R1 is 1, 0, 2, and add these two. So when we add, we get 0, 1, 5. And we have to put these values in R2. That's what it says. So that means R1 is going to remain the same, which is 1, 1, 0, 2. Only R2 we are going to replace by 0, 1, and 5. So this is the final answer. And number 6, we have replace R3 by 1/2 R1 plus R2. Okay. So let me write the augmented matrix here. Zero, 1. So we are going to replace R3. So we have to replace R3 by 1/2 R1 plus R2. So first we have to find 1/2 R1. What does that mean? You have to divide R1 by 1/2, 2. So that means 2 over 2, 2 over 2, 4 over 2, and 6 over 2. So that gives us 1, 1, 2, and 3. Okay, so now we have to add 1/2 R1 plus R2. So that means this is 1/2 R1, which let's write it down. And R2 is 1, -1, -2, 5. So now we have to add these two. So we get 2, 0, 0, 8. So that part is going to go to R3. So R3 is going to be 2008. And R1 and R2, we don't do anything to that value. So it's going to remain the same. So this is our final answer here. So number 7. The reduced row echelon form of the augmented matrix of the systems is given. We have to find the solutions. So it's a little bigger matrix here, but the solutions are going to be simple because we have identity matrix. That means all the non-diagonal elements are 0 here. So it's going to be pretty straightforward question. So you can take whatever the solutions, like the variables, you can say this is x, y, z, and w, or x, y, whatever. So we get from this one, we get x equals to 12. From the second one, y is 0. Z is -8. And then w is 11 over 12. So we can write the solution now. 12, 0, -8, 11 over 12. So the next one is number 8. Let me write the problem down here. So when you look at the equations here, so I'm going to put here x1, x2, x3, x4. So from the first equation, we can say x1 plus x4 equal to 12. The second equation is x2 equals a -8. And then we have x3 minus 2x4 equal to 6. And the last one, when you have all 0, we are going to say just x4 equal to x4. Okay, so now we can solve for x3. So from x3 minus 2x4 equal to 6. And that is then the second equation is x2 equals -8. So we have got the x2 as -8. Now x1 is going to be, let's take the first equation. X1 is going to be 12 minus x4. And so this is 12 minus x4. From x3 is going to be 6 plus 2x4. And x4 is x4. So the solution is 12 minus x4. x2 is -8. x3 is 6 plus 2x4. and x4 is x4. In number 9, we have to perform the augmented matrix, determine if the system is independent or dependent or inconsistent. So I'm writing down the equations first. Now we're going to write down the augmented matrix. Then we have to do some row operations. So this is our first augmented matrix. Now we have to reduce into row echelon form, which is we have to convert, make this one to 0 and this one to 0. So in order to do that, I'm going to do R1 minus R2 that goes to R2 first. So it's going to be 1, 1, 1, negative 1. So R1 minus R2 means this is R2, 0, 2, negative 2, 4. So it's going to, when you subtract 1, 1 minus 2 is negative 1. 1 minus, so minus 2 is positive 3. And then we get, so I'm going to put that one here. So 1, negative 1, 3, negative 5. And then for R3, I'm going to do, sorry, I made a mistake here. It's actually 1, 0. I'm sorry. Here we get 0, negative 1, 3, negative 4. I'm sorry, I made a mistake here. I wrote the wrong numbers here. Okay, so let me do it again. So when we subtract, this is what we are going to get. 0, 2, negative 2. I got the wrong numbers. And then I'm going to write down what I did for R3. So R3 is going to be negative 3 R1 plus R3. That goes to R3. Okay, so now we have to see. We can divide the last one, R3 by, again, we have to make this one into 0. So we just add so the operation, what I'm doing here is R2 plus R3 that goes to R3. Sorry, 0, negative 4, 4. And then we divide the last row by second row by 2 and the last row by negative 4. One half R2 goes to R2 and negative 1/4 R3 goes to R3. So when you look at this system, we can say the system is independent because we have solutions from the last row. So all we need to do is see if this is independent or dependent. We don't have to solve the equations. And we are going to do the last problem. Use the Gauss-Jordan method to solve the equations. So let's first write the equations here. So let's first write the augmented matrix. So here we're going to start first thing for the row operations. First thing we have to make the second, I'm going to circle this one. We have to make this one 0 and this one 0. So row 2 and row 1. So let's see how we are going to make it 0. So let's write, first thing is we have to check if the first row, first element is 1. We already have the 1, so we don't have to touch the first row. To do the second one, we are going to do R1 minus R2 that goes to R2. So when we subtract, we get 1 minus 1 is 0. 1 minus of minus 1 is 2, then negative 2 and negative 4. And we have to make that last one 0 as well. So it's going to be 4 R1 minus R3 that goes to R3. So it's going to be 0, 3, 3, negative 24. So in order to make it easier, what we can do is we can, since second row, we can divide everything by 2. So it's going to be 1/2 R2 goes to R2. And same thing, 1/3 R3 goes to R3. So it's going to be 0, 1, 1, negative 8. Just to make it easier we can make the easier steps. And then the next one, what we are going to do here is we are going to make the second row, third row, second element 0. So we are going to do 1, 1, 1, negative 12. So write this negative 2. So I'm making this one to 0. By doing R2 minus R3, R3 minus R2 goes to R3. So now divide this by 2. 0, negative 2, so we get negative 3. So it's going to be negative 1/2 R3 goes to R3. So now we can use back substitution. We get the last one is going to be z equals negative 3. And the second equation is going to be y minus z equals negative 2. And then plug in negative 3 for z. So we get y plus 3 equals negative 2. So subtract 3 both sides. So we get y equals negative 5. And from the first equation, we get x plus y plus z equals negative 12. So plug in y and z. Y is negative 5 and z is -2. So we get x minus 5 minus 2 is -12, or x minus 7 equals -12. Then add 7 both sides. So we get x equals -5. Oh, sorry, I think I put 3. Instead of 3, I put 2. Let me change. So it's going to be -3. So -8. So add 8 both sides. So we get -4. So the solution is -4, -5, and -3. And of course, you can check your solutions.